Welcome to Study Loop.
Hi everybody. So for this one, we need to find the speed of the hanging mass. Okay. And as it strikes the floor. And that's what this second image right here is showing, okay? You see how this mass? So what I'm gonna call is we're gonna call this part one. And actually let's do that in a different color. Let's do that in green. So we got one and we got two, okay? So for this first one, which we have it as one here, okay, we know that the mass is just going to focus on MGE, okay, and that is because it's hanging with gravity, and your kinetic energy initial is going to be zero, okay, because it's not moving. And for potential energy of 2, and so what we can do is potential energy of 2 is just going to be 0 because it's flying down, okay? And your kinetic energy of 2 is going to equal to 1/2 mass times velocity squared, and that's this one right here, your 1, plus 1/2 the inertia and the velocity squared, your rotational velocity, which is this one right here, okay, because you have this wheel that's moving, okay? And now we can keep going to just make it look nicer. We have mv squared plus 1/2, substitute capital M r, okay, r squared times velocity squared, okay, and what we can also do is sub in here for the rotational velocity divided by r squared, okay? And we can keep going, and what I'm going to do is we can cross these bad boys out. Perfect. And now we're going to use a law of conservation. So law of conservation, we have K1 plus kinetic energy plus potential energy equals kinetic energy of second system, second one, okay? And so here we have 0 plus mgh equals 1/2 mv squared plus 1/2 capital M r. Oops, not r. If I can say this right, v squared, okay, plus 0. We'll scroll down here. So as we continue, now we can take the GH, divide the M over. So we're taking the V squared out here, and I'm just gonna do V squared here. And because of this, we got M, capital M over baby M, okay? And we are gonna times this 2 over. So we got 2GH V squared equals V squared 1 plus capital M lowercase m. And that looks good. And we need to get the V over. So we have V over here divided by 2GH 1 plus capital M and lowercase m, okay? And that is your answer for A. And for B, what we have is, so for B, what we have is this expression here. So this expression is smaller than that for the solid cylinder, okay? And more of the cylinder, so, and then more of the cylinder. And if you need to shorthand all this, that's fine. You can draw a cylinder if that helps. Sometimes shorthanding your notes is easier, okay? More of the cylinder's mass is concentrated at its edge, kinetic energy is large because a moment of inertia is large. Okay, thank you guys.